Welcome to a lesson on the applications of proportionality and constant rate of change. Previously, we had talked about a water tank and how it was filling, and we used it as a way to determine what the quantities were not proportional, but the quantities were related by a constant rate of change. So again, in proportionality, we had three perspectives of proportionality: the scaling, the constant multiple, and the constant ratio perspectives. Likewise, we also talked about the constant rate of change, and what that meant is that two quantities are related by a constant rate of change if the changes in the quantities are proportional. And for this activity that we're about to do next, making sure you are familiar and understand the concepts that were in that video with the water tank are pretty important, and also the one with the gym, where we did an example looking at the changing quantities and determining whether the ratio of the changes was proportional or not. If it's a little bit rusty, I recommend you go back and review those. Okay, let's proceed. So we're going to be using both proportionality and the constant rate of change, and here's the puzzle. The values in this table are not proportional, but they are related by a constant rate of change. Find the missing values and complete the table. So we have delta t, we have d, and we have delta d in this table, and different values. And you notice that the spots that are blank are spots A, B, C, D, E, F, G, and H. What we're going to do is think back to the time when we were working with changes. And so if we were looking at the ending value is equal to the change in value plus the starting value. And then we also had the other relationship, which is the change in value is equal to the ending value minus the starting value. In this context, when we look at the first equation, that tells us that T2 is equal to delta T plus T1. And looking at the second equation, in this context, that means delta T is equal to T2 minus T1, where T1 represents the starting time and T2 represents the time that comes after. So what we're going to do next is look at and find and determine what the value of A is. And what we're going to do is use that subtraction relationship between changes. So we're going to take 20 minus 11, and 20 minus 11 gives us 9. Next, we're going to use a relationship where the ending value is equal to some change in value plus the starting value. So if we're looking at this, something plus 3 is equal to 11. Now that value has to be 8, because 8 plus 3 is equal to 11. And the second one over here, when we're looking for value of C, we could simply take 20 plus 7, and we get 27. That is the value of C. But so far, we have actually filled out the left half of the table. Now let's look at the right half. Looking at the right half, in this context, our first equation is going to be d2 is equal to delta t plus d1. And our second equation will be delta d is equal to d2 minus d1. Now, the only information that we're able to determine right now is E. So there's something plus 36, which would give us 42. And so what we're going to do is use that information. Something plus 36 is 42, so 6 plus 36 is 42. We could check our work by taking 42 minus 6. That would give us a change of t of 36. But as we're looking at this, so far, there's not much else we can do with this. So we're looking at this, and so far it looks like we don't have enough information to complete the problem. So let's reread the problem and see if we can learn some other facts that maybe help us make some progress. So reading it really carefully, notice that the quantities are related by a constant rate of change. So constant rate of change means that the changes in the quantities are proportional, which means that the changes in quantities can be related by a constant multiple, and that the changes in the quantities can also be related by a constant ratio. So the change in t times the constant multiple will be the change in t. And likewise, the change in d divided by the change in t is a constant ratio. Now that constant multiple and that constant ratio from earlier, that is referred to as the constant rate of change, abbreviated CROC for constant rate of change. What we're going to do is see if we can determine this constant rate of change in this problem. We are given some facts. We're given the fact that we know for delta t of 9, that corresponds to a delta d of 36. So we could, 36 over 9 is going to be the constant rate of change. Or from the constant multiple perspective, 9 times that constant rate of change will be 36. Regardless of which perspective you take, that when you find out what the constant rate of change is, the value of the constant rate of change has to be 4 for this to be true. And that constant rate of change will be true for all relationships that relate changes in quantities. So this means that any corresponding change in t times 4 will give you a corresponding change in d, and that the ratio of change in d over change in t will always be 4. So let's see how we can use that information. We're going to focus on the constant multiple perspective because our goal is to find out what that change in d is for every given change in t. So 3 times 4 will give us the change in d right over here for spot G, for cell G. So 3 times 4 is 12. Similarly, we can do some analysis with the change in t when it is 7. You take 7 times 4, that's going to give you the corresponding change in d. And so 7 times 4 is going to give us 28. So cell H is going to be 28. Now after this, we have the information, enough information to complete the remaining parts of this table. So we'll go back and remember what the relationship between changes are. We're going to focus on that idea of d2 is equal to some change in d plus d1. So first let's look at the finding cell F. So if we take 42 plus 28, that's going to give us 70. And what we're trying to also figure out is for d is what plus 12 gives us 6. Well, it's going to have to be a number that's less than 1, so when you think about it, negative 6 plus 12 is going to be 6. As a way to check our work, what you could do is take 70 minus 42. That does give us 28. And if you take 6 minus a negative 6, that does give you a positive 12. So the process is correct. And so this is a little bit, we have now completed the entire table. And so using the ideas of proportionality and the constant rate of change, we were able to fill out all the information that was missing. I hope you found this helpful.